A telephone line hangs between two poles 14 meters apart in the shape of the catenary. Y is equal to 20 hyperbolic cosine of x over 20 minus 15, where x and y are measured in meters. So we talked about how if you have a heavy chain wire cable hanging between 2 points like this, the function is a hyperbolic function, the function for that cable. Find the slope of this curve where it meets the right pole. So this slope here, we can see that this curve, this catenary they call it, it's x is equal to 0 at the center. So we want to find dy dx and then set x equal to 7, right? Because it's 14 meters apart. The poles are 14 meters apart. So dy dx, the derivative of hyperbolic cosine is hyperbolic sine. So 20 hyperbolic sine, but now the chain rule, so what is the derivative of x over 20? That's, okay, and then the derivative of 15 is 0, so dy dx is hyperbolic sine of x over 20. Okay, now what we need to know is, what is dy dx at x is equal to 7? Well, that's hyperbolic sine of 7 over 20. .357. And these units are, in this scenario, meters per meter, so it's just unitless, right? So that is the slope. Find the angle theta between the line and the pole. How do we find this angle theta? Well, we know the slope. So you can think about that as we know the slope triangle of this line here. What's the values on this slope triangle? It's 0.357 and 1. And this is theta right here. That's theta. So tangent of theta is opposite over adjacent. Tangent theta is equal to opposite over adjacent. .80. So theta is equal to if we want to get this in degrees, let's go to degree mode. So 70.3 degrees.